Hello students and welcome again. In the last lecture we began a discussion over a certain type of sequence which actually possess a beautiful behavior that any two consecutive terms if you take, the difference of any two consecutive terms in the sequence is a constant denoted by D. We generally denoted by D, and that is called the common difference. Okay, that means any two consecutive terms are equidistantly placed. Fine. Such a sequence which portrays such a fashion of listing of terms is called an arithmetic progression. Okay, we also discussed that whenever you have an AP, that is an arithmetic progression, any term of the AP can be written in terms of the first term of that AP and the common difference of that AP. So nth term of the AP is equal to A1, that is the first term, plus n minus 1 into D, where D is the common difference. Okay. So any term of the AP can be written as, or can be written in terms of the first term and the common difference, and conversely if you know the first term and the common difference, you can calculate any term of the AP. The second term will be A plus D, third term will be A plus 2D, fourth term will be A plus 3D, and so on. Nth term will be A plus n minus 1D. Now this general term concept of an AP, let's apply it in a question. If I am saying that suppose 5 terms I am giving to you. Let A, B, C, D, E be in AP. Now when I am giving you these 5 terms, they are in AP, that means you can consider this to be a finite sequence of 5 terms. You can consider this to be a finite sequence of 5 terms. These are 5 numbers itself denoted by A, B, C, D, E. This is my sequence where this is my first term, this is my second term, this is my third term, this is my fourth term, and this is my fifth term. So it's not an infinite sequence, rather it's a finite sequence with 5 terms listed like this. With ordering defined, A is the first term, B is the second, C third, D fourth, and E fifth. The question is, if these are 5 terms in an AP, then find the value of A minus 4B plus 6C minus 4D plus E. A, B, C, D, E are terms of an AP, where A is the first, B second, C third, D fourth, and E fifth. In that case, calculate the value of this. Now this question is directly related to the general term concept. See, B is the second term of this AP, right? I don't know the common difference of this AP, but I am sure that if these 5 terms are in AP, definitely the difference of any 2 consecutive terms is a constant. So as A, B, C, D, E are in AP, this implies B minus A is equal to C minus B is equal to D minus C is equal to E minus D. Suppose this is equal to the common difference D. Because small d has already been used, so that's why I denoted common difference by capital D. This is the case. I don't know what capital D is. Now, I have to compute the value of this expression. Let's write it down. Consider A minus 4B plus 6C minus 4D plus E. You know that whenever you know the common difference and the first term of an AP, you can write down all the rest of the terms of the AP in terms of the first term and the common difference. B is the second term, it can be written in terms of the first term and the common difference as A plus D. The third term C can be written in terms of the first term and the common difference, that is A plus twice of D. Fourth term will be a plus thrice of d. Fifth term will be a plus 4 times d. That means each and every term will now be written in terms of the first term and the common difference. So, a, leave it as it is, it's already in terms of the first term, minus 4 times b, which is the second term. Second term will be, or if you want, you can write this as an equals a1 plus n minus 1 into d, therefore a2. What is my second term? a2, a2 is b, b is equal to a2, which is equal to first term plus 2 minus 1 d, which is a1 plus d. Then c is nothing but the third term, which is a1 plus 3 minus 1 d, which is a1 plus 2d. Then d is the fourth term, which is a1 plus 4 minus 1 into common difference, which is a1 plus 3d, and similarly e, which is the fifth term, is equal to a1 plus 5 minus 1d, which is a1 plus 4d. That's how I express each and every term of the AP in terms of the first and the common difference. So here, minus 4 times b is what? a1 plus capital D. A, I can write this as a, because a1 is equal to a only. See, a1 is equal to a. So this becomes 4 times a plus d plus 6 times c. C is a plus 2d minus 4 times d. D is a plus 3d plus e. E is a plus 4d. Clear? Just open this up. What you get is a minus 4a minus 4d plus 6a plus 12d minus 4a minus 12d plus a plus 4d. See what you're getting? Plus 12d minus 12d cancels out. You have a minus 4a, which is minus 3a, minus 3a minus 4a, which is minus 7a, plus a minus 6a. So let's see what we have written. We have a minus 4b plus 6c minus 4d plus e. We wrote a as it is, minus 4, b was written as a plus d, 6 plus 6 times c was written as a plus twice of d, minus 4 a plus thrice of d plus a plus 4 times d. So we have a minus 4a minus 4d plus 6a plus 12d minus 4a minus 12d plus a plus 4d, and you will be able to see everything gets cancels out and you get a 0 finally. That's how the value of this expression, just by expressing each and every term b, c, d, e in terms of a and the common difference d, happens to be the rescue. Understood? That's how the concept of just the general term, understanding how each term can be written in terms of the first and the common difference, happens to be the very rescue to many of the problems. So general term concept is very important. Apart from general term, there is one thing which is utterly asked and is also something to be understood related to the sum of terms. So, if I talk about sum of n terms of an AP. If I talk about sum of n terms of an AP, if you have an AP with the first term and the common difference, everything is specified. I am asking you, what is the sum of n terms of an AP? Therefore, the concept is that the sum of n terms denoted by Sn. The sum of n terms denoted by Sn of an AP. The sum of n terms denoted by Sn of an AP with first term A and common difference D is given by Sn equals n by 2 2a plus n minus 1 into D. That's the very concept behind Sn. Sn is nothing but the sum of n terms of an AP. So if you have the first term with you, if you have the common difference with you, you can calculate the sum of n terms of an AP. Clear? And the formula is n by 2 2a plus n minus 1 into D. Based upon this particular concept of calculating the sum of n terms of an AP, sum of 15 terms of an AP, sum of first 20 terms of an AP, sum of first 28 terms of an AP, everything can be calculated just by this formula. And this formula results into very beautiful formulas which are utterly useful in mathematics, and they are, let's see what. The formulas are, first one, what is the sum of first n natural numbers? What is the sum of first n natural numbers? I'm asking you what is 1 plus 2 plus 3 plus 4 plus and so on up till n. So if I keep n equals 3, I'm just asking you what is the sum of first 3 natural numbers. If I keep n equals 4, I'm asking you what is the sum of first 4 natural numbers. That can easily be evaluated by the counting on fingers itself. But if this n is kept to be a pretty large natural number, in that case beginning from 1 to that large natural number, what is the sum of all the natural numbers? That becomes a task, and which is simplified by this formula of Sn. Why is Sn applicable over here? Sn is just to calculate the sum of n terms of an AP. Is this an AP? Well, over here, if you consider this sequence n, n plus 1, n plus 2 and so on, I have just listed all the natural numbers in their ordering form itself. So first term is 1, second term is 2, third term is 3, fourth term is 4. I have listed them, and this is very much an AP because you know, any two consecutive terms are having common difference 1. They are distant by 1 unit. They are all 1 unit apart. Any two consecutive terms are 1 unit apart each. That is why this is an AP, and over here what is written is the sum of first n terms of this AP. Sum of first n terms of this AP is this only. Sum of first n terms of this AP is equal to 1 plus 2 plus 3 up till plus n. This is equal to n by 2. 2 times A is 1, which is the first term, plus n minus 1 into D, common difference is 1. 2 into 1 plus n minus 1 into 1, this gives you what? Let's see, n by 2. This is 2 plus n minus 1. So 2 plus n minus 1 gives you what? 2 minus 1 is 1, so you get n plus 1. So this gives you n into n plus 1 by 2. That is it. This is the first question says that if the non-zero numbers 3 given are there, x, y and z, they are in AP, and tan inverse x, tan inverse y, tan inverse z is also in AP, then what is the relationship between these three numbers? So if x, y and z are in AP, that means twice of y is equal to x plus z, and if tan inverse x, tan inverse y and tan inverse z are also in AP, that means again that twice of tan inverse y is equal to tan inverse x plus tan inverse z. Right? Twice of tan inverse y means tan inverse 2y upon 1 minus y square. Right? Tan inverse x plus tan inverse z means tan inverse of x plus z upon 1 minus xz. If these two things are equal, that means their arguments are same. 2y upon 1 minus y square equals x plus z upon 1 minus xz. Now 2y is equal to x plus z. The numerators are equal. So automatically for these fractions to be the same, 1 minus y square equals 1 minus xz. This eventually means y square equals xz. So x, y, z are in AP. From here you can say x, y, z are in GP. So if three numbers are in AP as well as GP, then that only means that they three are equal. So we began with these three terms being in AP. Because of the second very argument given to us, we concluded that they are in GP as well, and therefore all these three numbers have to be same. Only then can they be in both AP as well as in GP. So that's how we deal with this question. Let's move on to the next one. Second question says that if three positive real numbers are in AP such that their product is 4, then what is the minimum value of B? Okay, so if A, B, C are in AP, that means B minus A is the common difference D, and that is same as C minus B. This means what? This means that A is B minus D, and it means that C is D plus B. Now if A into B into C is given to me as 4, what is A into B into C? A is B minus D, B is B, and C is B plus D. This is 4. This means B into B square minus D square is 4. Now, you know that B square minus D square is obviously less than B square. You can just take it strictly less as well. Fine. So B into this is less than B into this. So you get B into B square minus D square is less than B cube. But B into B square minus D square is actually 4. So 4 is less than B cube, or B is greater than 2 to the power 2 by 3. If B is greater than 2 to the power 2 by 3, that means minimum value is this. You can take it to be equal to, and then you are going to get it to be the minimum value. What is the minimum value? 2 to the power 2 by 3. Now the next question says what? That if B minus C, 2B minus X and B minus A are in HP, harmonic progression, then A minus X by 2, B minus X by 2, C minus X by 2 are in what? So if these three terms are in HP, that means their reciprocals are in AP. So if the reciprocals are in AP, that means 1 upon B minus C, 1 upon 2B minus X, and 1 upon B minus A, they are in AP. This eventually means twice of the middle one. Twice of the middle term is equal to sum of the first and the third. So 1 upon B minus C plus 1 upon B minus A. Very, very easily you can resolve this expression completely, and what you are going to get is B minus X by 2 whole square is equal to A minus X by 2 into C minus X by 2. Which means that what? B minus X by 2 whole square equals A minus X by 2 into C minus X by 2 means that A minus X by 2, B minus X by 2, C minus X by 2, they are in GP. So if These three terms are in HP, their reciprocals are in AP, because of which this is the relationship between them. Resolve it, you get this, which means A minus x by 2, C minus x by 2, B minus x by 2, they are in GP. Moving to the next question, if the first two terms of a harmonic progression are given to you as 2 by 5 and 12 by 23. So if they are given to you as 2 by 5 and 12 by 23, then the largest term is what in this HP? So the first two terms, first term of an HP is 1 by A, second term is 1 upon A plus D, because their reciprocals are in AP, right? 1 upon A is given to you as 2 by 5, 1 upon A plus D is given to you as 12 by 23. From here you can say A is 5 by 2, and again from here you can resolve and you can get D is minus 7 by 12. Nth term of the HP is given by what? 1 upon A plus N minus 1 into D. You have A, you have D, you are going to find this out. This is going to come out to be 12 upon 37 minus 7N. I want that N for which I can get the largest term. Now you can see if you put N equals 1, you get 12 upon 37 minus 7. See, one thing you understand, for this complete fraction to be the largest, the denominator has to be the least. This is going to be largest when the denominator is the least. For which n the denominator is the least, you can very clearly see, you can plug in n equals 1, 2, 3, 4, 5. At 5 you will have to stop because 6 is going to exceed it again. At 5 if you stop, you get 37 minus 35, which is 2. That is the least denominator you can get, for which you are going to get the largest value of this fraction, because if you move ahead of it, you are going to get negative in the denominator, which eventually is going to make the entire fraction negative, which is going to make it smaller in magnitude, right? So that is why for this complete fraction to be the largest, the smallest positive quantity which this denominator can gain is 2, that is when this difference is 2, that means when this is 35, which means when this is 5. So for n equals 5, that means for n equals 5 I am getting this term becoming the largest. So fifth term of this harmonic progression is the largest. Answer is option number A. Okay. What is the next question? Let's see if 3 arithmetic means, 3 geometric means and 3 harmonic means are inserted between 1 and 5. Okay. Then find the cubic equation whose roots are first AM, second GM and third HM between 1 and 5. So see, situation is, this is 1, this is 5, A1, A2, A3. 3 arithmetic means are inserted. I am only interested in the value of first arithmetic mean, which is what? It is A plus D, where D is B minus A upon n plus 1. So what is A1? A is 1, see, this is A and this is B. So 1 plus B minus A, 5 minus 1, that is 4 upon n is 3, 3 plus 1 is 4, you get 2. So 2 is the first arithmetic mean. Again, if you have 3 geometric means inserted between 1 and 5, what is the value of the second geometric mean? It is AR square, where R is B upon A to the power 1 by n plus 1. So A is 1, R is B by A, that is 5 by 1, square to the power 1 by n plus 1. So 1 upon 3 plus 1 is 1 upon 4 into 2, so 2 upon 4. This is root 5. And similarly, if between 1 and 5, you have 3 harmonic means inserted. If between 1 and 5 you have 3 harmonic means inserted, I am only interested in the value of the third harmonic mean. I know that 1 upon H3 is 1 upon A plus 3D, where D is A minus B upon n plus 1 into AB. And therefore 1 upon H3 comes out to be 1 upon 1, because A is 1 plus 3 times A minus B, 1 minus 5 whole upon n plus 1 into AB. So you get 1 minus 3 by 5, that is 2 by 5. So H3 is 5 by 2. That's how you get the first arithmetic mean, second geometric mean and third harmonic mean. These three are the roots of a certain equation, cubic equation. And when you know all the roots of this cubic equation, you can get the cubic equation, isn't it? The three roots are what? Suppose I am saying the first root is what we got 2, second was root 5 and third was 5 by 2. What is that cubic equation? It is x cube minus sum of the roots. Sum of the roots into x square plus sum of product of roots taken 2 at a time. So 2 into root 5 plus root 5 into 5 by 2 plus 5 by 2 into 2 into x minus product. So it is 5 root 5. That's the constant term. X cube minus sum of the roots into x square plus sum of product of roots taken 2 at a time into x minus product of the roots. And this is what, if you resolve, you get the first option as the correct one. Clear? Now moving on to the next, we have the sixth one, which talks about the series now. What does it say? Let's see. It says the sum of n terms of this series is what? Okay. So let's talk about this. What is the nth term? Nth term of this series will be 1 plus 3 plus 5 plus 7 plus and so on to n minus 1. What is this? What is this? I can write this as summation to r minus 1, r going from 1 to n, right? For r equals 1, this is 1. For r equals 2, it is 3. For r equals 3, it is 5. For r equals n, it is 2n minus 1. This gives you twice of summation r going from 1 to n minus 1, which is twice of n into n plus 1 by 2 minus 1, which gives you n square. This is actually summation r going from 1 to n till 1. 1 plus 1 plus 1 n times gives you n, so you get n square plus n minus n, which is n square. This is the nth term. You need to add the nth term. Basically, you need to find the sum of first n terms of this series. So you basically need to find what? Summation r square, r going from 1 to n, right? Because that's what we've got. So it is n plus 1, 2n plus 1 by 6, and that is your answer. So just generalize the very nth term. You need to add the nth term n times basically, right? So it is summation r square, r going from 1 to n. Okay? So the first term is this, second term, third term. You need to add, basically find the sum of n terms of this particular series. Clear? And that is coming out to be n plus 1, 2n plus 1 by 6. Now we have the next question in the league. It says if n is even, then the sum of n terms of this series is what? So n is even. Now please observe the very expression carefully. If you are going to see, with even numbers there is a minus sign, with odd numbers there is a plus sign. With even there is minus, with odd there is plus. So if this series stops at an even number, it is going to look like what? 1 square minus 2 square plus 3 square minus 4 square. End is even, so it will be minus n square. Before it is odd, so it will be plus n minus 1 whole square. 1 less. 1 less. So here it is even, so minus, 1 less with plus sign. So this is what you get. Now when you eventually open this up, what is it that you obtain? You get a square minus b square. It is a plus b, a minus b, again a plus b, a minus b, again n minus 1 minus n, n minus 1 plus n. You solve this, you get 1 plus 2 plus 3 plus and so on till n, which is negative of n into n plus 1 by. First question is if log 2, log of 2 to the power x minus 1 and log of 2 to the power x plus 3 are in AP, then what is the value of x? The very fact that these three terms are in AP means that twice of log of 2 to the power x minus 1 is equal to log 2 plus log of 2x plus 3. Right, so from here you get log of 2 to the power x minus 1 whole square equals log of 2 into 2 to the power x plus 3. You know log to the base e is a 1 function, so this implies 2 to the power x minus 1 whole square equals 2 into 2 to the power x plus 3, which means 2 to the power x whole square, which is 2 to the power 2x plus 1 minus 2 into 2 to the power x equals 2 into 2 to the power x plus 6. So what are you left with is 2 to the power 2x minus 2 into 2 to the power x minus 2 into 2 to the power x, which is minus 4 into 2 to the power x plus 1 minus 6, which is minus 5. Okay, so from here when you basically break the middle term, you get 2 to the power x minus 5 into 2 to the power x plus 1 equals 0. Now I know that this can never be possible, that this is equal to 0. Why? Because 2 to the power x is never negative. So if this is equal to 0, you basically get, what do you get? 2 to the power x equals minus 1, which is wrong. And therefore for this expression to be 0, 2 to the power x will have to be equal to 5, or x will be log 5 to the base 2, and therefore the value of x is log 5 to the base 2 for these three terms to be in arithmetic progression. Next question says what? It says that a, b, c are in AP and a square, b square, c square are in HP. If a, b, c follow what? So a, b, c are in AP means that twice of b equals a plus c, and a square, b square, c square are in HP means that b square equals twice of a square, c square upon a square plus c square. Clear? Now it says that if they are in HP, then what is the condition between a, b, c which they are going to follow? So understand, over here if I just eliminate b, because b is a plus c by 2, I plug it in over here, I get a plus c by 2 whole square equals 2a square c square upon a square plus c square. So from here what do you get is a square plus c square plus 2ac equals 8a square c square upon a square plus c square. So this eventually gives you what? Let's see. This gives you a square plus c square whole square plus 2ac minus 8 a square c square equals 0. So you basically land yourself to the step a plus c whole square plus 2ac multiplied by a minus c whole square equals 0. So either this is 0 or this is 0, only then this product can be 0. So if a minus c whole square is 0, this means a minus c is 0, which means a equals c. But if a is equal to c, you get 2b equals 2a, which means b equals a. So eventually you will get a equals b equals c. So this expression is 0, or this and this, both of them are going to hold simultaneously if a equals b equals c. This is one very condition in which they are going to hold. Another condition is that if this is 0, that means a plus c whole square plus 2ac is 0. Now a plus c is twice of b, so you basically get twice of b whole square equals minus 2ac, right? Which means b square equals minus 1 by 2ac. I can write this as minus 1 by 2a into c, or I can write this as a into minus 1 by 2c. B square equals minus 1 by 2a into c means minus 1 by 2a, b and c are in GP, and b square equals a into minus 1 by 2 c means a, b and minus 1 by 2 c are in GP. So either this holds or this holds, even then in that situation this particular product will be 0, and hence both these facts of AP and HP are going to hold simultaneously. That means when AB and minus half C and minus half ABC are in GP, these are the three conditions, the three very situations where ABC will be in AP and A square, B square, C square will be in HP. Next question says what? That ABC are real numbers and ABC are in AP. Match the expression in column 1 with the properties or conditions in column 2. Let's see how do we need to tackle with this question. So ABC are already given in AP, that means you already have that twice of B equals A plus C. A square, B square, C square are also in AP, that means twice of B square equals A square plus C square. This is already given to you. Fine. Now A plus C whole square is what? A plus C whole square is 2B whole square. Right? What is 4B square? It is twice of 2B square. But 2B square is A square plus C square. So this is 2A square plus 2C square. This is A plus C whole square, which is A square plus C square plus twice of AC. Now 2A square minus A square is A square, 2C square minus C square is C square, minus 2AC gives you A minus C whole square is 0, which means A equals C. If A comes out to be equal to C, again B comes out to be equal to A, comes out to be equal to C. So you basically get A equals B equals C. So the first point gets matched to P. So corresponding to A, you basically shade P. Clear? Next you have A square, B square, C square are in GP. Okay, so A, B, C continue to be in AP. It's given that A square, B square, C square are in GP. That means B square whole square equals A square, C square, or B square can be written as plus minus AC. Now if B square equals AC, this means A, B, C are in GP. And if ABC come out to be in GP, ABC are already given in AP, that means again A equals B equals C. So ABC are coming out to be in GP, they are already given to be in AP, and therefore A equals B equals C. So corresponding to B also, option P is what comes out to be correct. Third we have A square, B square, C square are in HP. Let's see. A square, B square, C square are in HP, that means B square equals twice of A square, C square upon A square plus C square, right? Again, because they are given in AP, exact same argument like we did in the previous question. Here also again, B will be replaced by A plus C by 2. And this is how the expression is going to just be in terms of A and C. Fine. Now when you simplify, you get A plus C whole square plus 2AC multiplied by A minus C whole square equals 0. Again you get either A equals C, which eventually would mean A equals B equals C, or you are going to get that if this is equals to 0 means what? A plus C will be replaced by 2B. So you are basically going to get from here, if this is equal to 0 means that A or minus 1 by 2A, B and C are in GP, or A, B minus 1 by 2 C are in GP, and from here you are going to get that A equals B equals C. So corresponding to option number C, P, Q, R, all three are going to be shaded. P also, Q also, and R also. Fine. Then you have D, that is A plus B plus C is 3 by 2. Then what among those are going to hold? So if A plus B plus C is 3 by 2, so you have A plus B plus C is 3 by 2. You already know A plus C is twice of B. If A plus C is twice of B plus B is 3 by 2. Thrice of B is 3 by 2, B is 1 by 2. So D is basically going to be shaded to S. Fine. Moving on to the next question we have, suppose 4 distinct positive numbers. So suppose 4 distinct positive numbers A1, A2, A3, A4 are in GP. If that is the situation, I am going to say let the first term of that GP be small a and the common ratio be small r. So you get A1 is A, A2 is AR, A3 is AR square and A4 is AR cube. B1 is A1. So B1 is A. B2 is B1 plus A2. B1 is A and A2 is AR. So A plus AR, which is A1 plus R. B3 is what? B3 is B2 plus A3. B2 plus A3. B2 is B1 plus A2. B1 is A plus A2. What is it? A. B1 is A plus A2. So we've already written that. B3 is B2 plus A3. That means A1 plus R plus AR square, which means A common 1 plus R square. And similarly you get B4 as A common 1 plus R square plus R cube. Statement 1 says that B1, B2, B3, B4 are neither in AP nor in GP. Let's check. If I talk about AP, what is B2 minus B1? B2 minus B1 is A plus AR minus A, which is AR. What is B3 minus B2? B3 is A plus AR square minus A minus AR, so you have AR square. And these two are not equal. So yes, B1, B2, B3, B4 are not in AP. But are they not in GP also? Let's check that they are in GP or not. So if I talk about B2 by B1, B2 is A 1 plus R, B1 is A, so you are just left with 1 plus R. And B3 by B2, B3 is A 1 plus R square, and here you have A 1 plus R, so you can very clearly see that both of them are again not coming out to be equal, so they are not in GP as well. And therefore statement 1 is true that they are neither in AP nor in GP. Are they in HP? Are they in HP or not? So for HP, what do you check basically? What do you check for HP? That the reciprocals should be in AP. So B1, B2, B3, B4 are in HP or not? That means 1 by B1, 1 by B2, 1 by B3, 1 by B4 are in AP or not? So for that, 1 by B2 minus 1 by B1, if it comes out to be equal to 1 by B3 minus 1 by B2, that means yes, they are in AP, but you are going to find they are not going to come out to be equal, in which case the reciprocals are not coming out to be in AP, so the terms will not be in HP. So these terms are in HP, this is false and this is true. Statement 1 is true and statement 2 is false. Clear? Next is this particular series is given to us. Statement 1 is giving you the sum of this series, statement 2 is also given, so which is giving you the correct sum is what we need to find. So here, if you carefully observe this, it's already given to you, the general term is given to you, TR, that is the rth term is given as R square upon 2R minus 1, 2R plus 1, we need to compute the sum. So what we do is, we first of all multiply 4. Why am I doing that? Because when you multiply this, you get this. So you get 4 times TR equals 4R square minus 1 plus 1 upon 2R minus 1, 2R plus 1. So I have created this particular product above also, that is 4R square minus 1 plus 1. Why? Because now I can write this as 1 plus 1 upon 2R minus 1